6.3, we are multiplying and dividing rational expressions. Our EQ is how can you determine the excluded values in a product or quotient of two rational expressions. We've been working with rational expressions for the last few sections now. So we've looked at y equals a over x, we've graphed it out, we've translated them left, right, up, down, all that good stuff. So what we're doing today is we're going to be multiplying them specifically. This chapter or this section looks at both multiplying and dividing. I'm going to split that up into 2 days. We're going to multiply today, divide tomorrow. First core concept, I think we all already know this concept. If we look at this, our concept is basically, if I have A times C over B times C, I can simplify this, right? What's going to cancel out?
C.
C. So basically, if I have the same number in the numerator and the denominator, they'll cancel out. If I have the same variable in the numerator and the denominator, they'll cancel out. If I have the same expression in the numerator and the denominator, they will cancel each other out. So if I think about this in terms of numbers, if I have something like 15 over 25, I can rewrite this as 3 times 5 and 5 times 5, right? And I have something in common on top and bottom. What's going to cancel? 5. So we're dividing out our common factor of 5, and we're left with just 3/5. And basically, this is how we reduce fractions. And we kind of do this in our head, right? We just factor out what they have in common. Does that make sense? Yes. These two 5s, if I multiply 5 times 5, I get 25. I'm just kind of breaking it up into factors. Good question. So if I take this a step further, I can cancel out more than just numbers and variables. So if I have something like this, do I have anything in common in my numerator and denominator here?
Yes.
Yeah. What is it?
Parentheses x plus 3.
Yeah, so these guys are going to cancel each other out. So I can do more than just a number and more than just a variable. I can do a whole expression. So that entire expression is going to cancel, and I'm going to be left with 4 over x plus 3. Not so bad, right? Pretty basic stuff. All right, so let's take a look at some examples. To simplify a rational expression, we want to follow 2 steps. Can someone read these 2 steps for me, please?
Factor the numerator and the denominator.
Good, and then?
Divide out any common factors, cancel out the same expressions.
Good. So I want to start by factoring top and bottom, and then if I have anything that's the same, I can cancel them out. So take a look at example 1. Do I have anything in common with all 3 of my terms here? X. So I can factor out x on the top and the bottom here. So what that looks like is this. If I look at the top here, I can factor out an x. If I take an x out of x squared, what's left? Just 1x, right? If I take the x out of 7x, then I'm left with just 7. And with my denominator, I can do the same thing. Can I factor out x from x squared? Yeah, this is going to be x times x. What cancels? X. Can I cancel out these 2 x's? Maybe? Why yes or why no? They have the same exponent? Is that what you're saying? So I can cancel them? Or I can't cancel them? No. I have something around that top expression, right? What do I have? I have parentheses. So that means that my x plus 7 is one piece. I can't separate them. So that means I can't cancel these guys out. It's going to stay as x plus 7 over x. Does that make sense?
Yeah.
So when I have these parentheses are holding these two things together. So if I had x plus 7 on top and x plus 7 on bottom, then that would work. But I can't just cancel out a singular x. So my answer ends up being x plus 7 over x. Because I have a fraction here, and I have a variable in my fraction, I need to put a stipulation here. I need to have some kind of rule. X cannot be equal to what number? What number can I not have in my denominator? 0, right? If I have 0 in the denominator, then I no longer have a valid answer. It's undefined. So this works as long as x doesn't equal 0. Questions on this? Cool. Let's take a look at the second one. With this one's a little more involved. We want to both factor the numerator and denominator, and we want to simplify it. So, do we remember how to factor? No? Okay, so we have ax squared plus bx plus c. We have a trinomial, yeah? Normally when I'm factoring, I want to find the factors of my c term. So what two numbers can I multiply to make 12? 6 and 2. Anything else? 3 and 4. 1 and 12. Of these pairs, which ones can I combine to make a negative 4 here? Yeah, negative 6 and positive 2, right? Because if I do negative 6 plus 2, that gives me negative 4. So my factored form is going to be x minus 6, x plus 2. Remember this, right? It's kind of coming back to us. Questions so far? No. So we also want to factor the denominator there as well. I can do that, but I'm missing something in my denominator. Remember, it's usually ax squared plus bx plus c. So what am I missing? A, b, or c? Yeah, b, right? Because it's ax squared. That one has an x squared. Bx has an x. And c is just a number. Do I have a number with an x next to it? No, so I'm missing my b term. So my b term is technically 0. Do I have factors of 4 that make 0?
Negative 2 and positive 2.
Absolutely. If I do negative 2 and positive 2, these will add to make 0, and my middle term is 0. So my factored form would be,
X plus 2, x minus 2.
yeah. What cancels here?
X plus 2.
X plus 2 is going to cancel on top and bottom, right? Because we have the same expression. So what am I left with?
X.
Beautiful. I still need to state which x value is no good here. So what I want to do is I want to look at what I canceled. If what I canceled out, if that expression is equal to 0, then that's no good. So what number can I plug into this expression to make this equal 0? Positive or negative? Negative, right? Because negative 2 plus 2 is 0. So that means that the number that I'm excluding is x cannot be equal to negative 2. And again, we're looking at that one that we canceled out. Does this make sense? All right. So I know there's a lot of information all at once, but see if you guys can figure out part C. Factor the top, factor the bottom. See if anything cancels out here. The top can equal it, it's fine. But we just don't want the bottom. Then it gives me
Because I came back, remember I came back, and I was like, which one are we doing? And then I had to hurry and write all this account. That was, which one was that? That was the MS612. So we usually spend 2 years. So, this one? So we're on this one, this one. No, not this one. This one. Because I sure came back and I was like, which one is going on? I had to write it down. Okay, cool. I'll have to like. Wait, I think I did write it down. No, I didn't.
Alright, let's go through this. I think we need a little bit of factoring practice, but that's okay. We'll get there. Factors of -3. What two numbers can I multiply to make 3? 3 and 1, right? And if I want my 3 and 1 to add to make -2,
Negative 3 plus 1.
yeah, I need to have a -3 plus 1. So my factored form is going to be
X plus 1, X minus 3.
good. Questions on this? We're good? Cool. So we're doing the same thing for the bottom. What are my factors of 6?
Negative 6, positive 3, negative 6, negative 3, 6 and 1.
If we're trying to make -1,
Positive
yeah, -3 and +2, right? So we're trying to make a -1. our middle term. So our factored form is going to be
Plus 2.
+2 and x minus 3. What cancels here? 3. So we have x plus 1 over x plus 2. And what can x not be equal to?
3.
Well, we're looking at what we canceled, right? And we don't want this expression to equal 0. So what do I plug in here that will give me 0? Positive 3, right? So x cannot be equal to 3. Questions on this? Is it getting a little better? Okay, I have one last thing that I want to cover. I'll try to go through this fairly quickly so you guys have time to work on today's classwork. Let me know if you need a little bit more time to copy this down. All good? Cool. So last thing I want to talk about is actually multiplying these guys. So far, all we've done is simplify them. And the title of this section is multiplying and dividing. So I want to look at actually multiplying these guys together. And it's not too bad, I promise. Basically, our property here is if we have A over B and we multiply C over D, when we're multiplying fractions, we just need to multiply straight across. So what this ends up giving us is AC over BD. And once we multiply these, we can simplify them if we need to. So for example, I'm gonna give you guys a full example here. Let's say I have, we'll do 5x squared over 2xy squared times 6xy to the third over 4y. So this looks a little daunting, but I promise you it's not that bad. Like I said, when we're multiplying fractions, we just need to multiply straight across. As long as we remember how to multiply, this should be fairly simple. So I've got three main pieces that I'm looking at here. I have my coefficients, or the numbers that I have up front. I have x, and I have y. And what I can do is break it down by each piece that I have here. So I'm gonna start with just my coefficients, or just my numbers. On my numerator, what numbers do I have? 5 and 6. What is 5 times 6? 30. 5 times 6 gives me 30. In my numerator, I also have x squared and x. We did this for our warm-up, yeah? If I do x squared times x, what do I get? X to the third power, or x cubed. Am I multiplying y with anything? No, so I can just rewrite it as y to the third. I'm going to do the same thing for my denominator here. What are my coefficients for my denominator? 2 and 4, and if I multiply that, I get 8. Multiply my x's, what does that give me? Sorry, do I have another x? No, so I just write x. And my y's? Yeah, y to the third. So multiplying straight across, not too bad, right? Any questions on how I multiplied this? Cool. From here, we can simplify. Can I simplify 30 over 8? Why did I do this? Did I do this wrong? I did it wrong. It's okay. It's okay. Yes. Yes. If I simplify 30 over 8, can I reduce my fraction here? These are both divisible by 2. So I get 15 over 4. Does that make sense? If you need help simplifying your fractions, Desmos does it for you, so you're more than welcome to use that. X. I've got 3 x's on top and 1 x on bottom. If I cancel them out, how many am I left with? 2 on the top, right? So that's going to be x squared. And what happens to my y's? They both cancel. Not so bad, right? So it looks pretty crazy, but once you kind of break it down, it goes pretty quick. And the math itself isn't super difficult. So see if you guys can take this and apply it to 2a. I'll give you guys a few minutes to work through it. And I think we'll call it after this example because these notes are pretty long.
We have to show our work. Yeah, I know, it's not good. And also it's just more fun.
Looks good. So let's go through this. If I multiply 8 times 7, what does that give me? 56. X to the third times x to the fourth. X to the 7th power. And y to the first times y to the third is y to the 4th power. In my denominator, what do I get?
8.
8 X.
Power three.
y to the 3rd power. Good. Can I simplify this?
Yes.
Absolutely. 56 divided by 8 is 7. If I have 7 x's on top, 1 x on the bottom, they're going to cancel out and I'm left with 6, right? So x to the 6th. 4 y's on top, 3 y's on bottom, cancel out 3, so I'm left with 1 on top, right? So it's going to keep 1 y up here. Do I have any denominator? Everything canceled out, right? So this is my final answer. Not so bad. Questions? Cool. I'm gonna call it here just because, again, I think we've done enough stuff today. So don't forget to write a summary. Please do write summaries, and please don't write, I learned rational